Welcome. Thank you for joining our Information Technology Best Practice Series webinar. I'm Becky Melody, your hostess for today's presentation. Sabu Vis, our IT Infrastructure Practice Lead, will be presenting. The discussion today will cover introductions, webinar logistics, direction for post-webinar collaboration, and our discussion topic, disaster recovery in the life sciences. USDM is focused exclusively on the life science domain. We're the market leader in providing IT, quality, and regulatory compliance professional service solutions. We're headquartered in Ventura, California, and we are a compliance partner for many best-of-breed vendors, including Oracle, SAP, OpenText, and Agilent Technologies. We've delivered more than 1,000 successful projects with over 130 life science clients, and we're the preferred compliance partner for small, mid-tier, and large life science companies. We specialize in assisting clients with reducing regulatory risk while maximizing their investment in quality systems, ECM, laboratory instruments and systems, and IT infrastructure. USDM is all about performance and compliance. Our directive is to simplify, unify, and optimize compliance and business objectives. I'd like to introduce Sabu Vis, our presenter. He has 15 years in technology and regulated life science domains. Sabu leads the USDM IT infrastructure practice, and he's our subject matter expert for VMware as well as SharePoint. The content today will be covered in 30 minutes, and then we'll invite you to post questions for our team via the iLink message board on the lower left of your screen, or you can join the discussion on LinkedIn and post questions there. If you're having any difficulties logging into the system, we suggest you turn off your pop-up blockers. The overall goal of the webinar today is to facilitate discussion, share ideas, provide the platform, get to the edge, and explore solutions together. Thank you for joining us, and now I'll turn the presentation over to Sabu.
Good morning, good afternoon, or good day, depending on where you're logging on from. It's a pleasure to present in front of all of you. Since it is just a half-hour webinar, I'm going to talk about a few concepts, and I'm going to dive straight into a real-life case study and talk about how we achieved some disaster recovery solutions, or deployed some disaster recovery solutions for a customer of ours. So that way it kind of gets you thinking a little bit, and perhaps you can post some questions to me towards the end of the webinar or throughout the webinar using the chat, either the private chat, public chat, or you can email and join the LinkedIn discussion board as well, and I'll get back to you to each and every question. So what is this webinar about, or what's the premise here, or what's your role, or why are you interested? I mean, the way I look at it is you're looking to see how you can automate disaster recovery or build disaster recovery capability. So much so it's like the press of the easy button, right? Like the Staples easy button. And why is this important? Why do anything? We hear a lot of the news, in the news about Japan, about earthquakes, and all of us here at USDM. At least my team is located in California, so we're already worried about earthquakes and disasters associated with that. It's really important to do something, because if you don't do anything, really the recovery of your systems in case of a disaster will be based on best efforts. So that can be a very, very arduous undertaking. The actual recovery time achievable can be days or even weeks. You'll actually have to build servers and your systems out on the other side of your new data center. Excuse me. Actually install your application, validate it, and things like that. So it's very, very important to kind of put together a good disaster recovery plan. The goal is to really achieve a proven structured mechanism for recovery with minimal data loss or user impact. What does that mean? You want to be able to recover from a disaster in a relatively short time, depending on the disaster, and you don't want to lose a lot of data. You don't want to go back to a backup from a week ago and lose a week's worth of work. And you also want to try and minimize the impact to the user, because many users are going to be logging onto your applications globally for most of our customers. So they just need access to the application, and we need to get that up really quickly. So let's talk about a typical system, because I think it's very important to dive into that real quick, and we'll discuss some technologies and some methodologies and how we can build some disaster recovery for the system. Right? So your typical system will contain will contain a web server where people log on to, perhaps a couple of app servers, clustered app servers, etc., and then transactional data that's stored in either files, a file share, or database, SQL, Oracle, etc. So this is quite standard and quite typical. So I'm going to pose this question out there, and I want some responses, and you can respond using the public chat or the private chat. In your mind, what do you think you really need to recover a system that I just described? What are the hurdles in establishing a disaster recovery program? You have an application that you're supporting. What do you think you need to recover that system in case of a disaster? So I'll give you a couple of minutes to pose your chats to me. Good. We need hardware to run the application. That's what Josh says. Bob says that you need a similar setup on the other side, meaning I think he means if you have an application on this side, you want to have a standby application on the other side. That's correct. That's right. Jeff replies saying, even though you have an application on the other side, we probably need some transactional data that's copied over to the other side. Obviously, your application, your live application is manipulating and generating data. You want to make sure that data gets across to the other side. All good answers. All good answers. So three things that you really need are, like Bob said, we need a standby environment. So if this is your production environment on your left-hand side, you need a similar setup on the right-hand side, and the right-hand side is your secondary data center. Again, have a web servers, app servers. You build out the application, maintain this with change control, etc. That's a good thing that you need. Second hurdle that you have to overcome is transactional data. You want to be able to translate or to replicate your data files or your databases across every X minutes or so based on recovery time objectives. You want to be able to replicate this data and this transactional information across from your primary data center to your secondary data center. And the third thing that no one mentioned is, you should have this easy button. And I'm going to kind of walk through a product called Site Recovery Manager, because this is part of our case study as well. So we use Site Recovery Manager to automate some of the steps to recover the application over to the other side. So let's step through each of those hurdles, right? So I step through hurdle one is to have a standby environment. Hurdle two is to make sure that you have transactional data that's pumped across to the other side every so often, every X minutes, 15 minutes, an hour, in real time. And the third hurdle is to have a way of recovering that standby environment and making that standby environment the production environment after a disaster happens. So let's go through the first hurdle. The first hurdle is the standby environment. So some considerations that we had to take for this customer. The big push or the big initiative for this customer was to minimize the server footprint or the environment footprint and the carbon footprint. I mean, already this is a life science customer. We already had to deal with dev, a validation environment, and a production environment. And the costs were racking up to have another environment which is just sitting idly on the secondary data center as a standby environment. So that's 4 environments now. And 3 of those that need to be maintained through change control. So it's starting to add to some level of, to the level of complexity of maintenance of these environments. So the VP of IT's push was to minimize the number of environments, and so that was an interesting challenge. So one of the things that the team decided to do was to move the pre-production environment or the validation environment over to the secondary data center, and that validation environment serves as the val environment when during normal operations, that is before a disaster, without a disaster situation taking place, and it would serve as the production environment in case of a disaster. And I'm going to walk you through how we achieve that. So we're going to repurpose the val environment to support prod in case of a DR, and kind of prepare that environment to work in a dual state, or it has 2 flavors to it. The normal flavor is val. In case of a disaster, it served as the DR's production environment. Of course, the application layers would be the same. We have to manage these the val environment as well as the production environment using change control. So the application layer is the same. The only thing that's really changing is the transactional data. So we would create a target data stores, whether it's a database or file shares or file system, etc., that will receive transactional data every so often from the production environment. So this is how that setup looks, and I want you to kind of spend some time going over this figure. So the users are logging on, and of course the left-hand side is the production data center, the right-hand side is the secondary data center in case of a disaster, right? So the users would log on and they would type in app.url, and they would be routed to the production environment, which you guys are all familiar with, and we saw this a little earlier today, right? And anybody who wanted to use the val environment, say wanted to do an upgrade, etc., would use the val URL and log into this environment. And I really want you to pay attention to these squiggly lines here. This environment serves as val mode. And if you notice, there's a data store here, which manages all of the validation data. This is another data store which manages all the validation data as well. So this is an application, say, like an ECM system that has a relational database, but also has file folders where the actual documents are stored, right? So those are 2 types of data stores: a file share as well as a database. Now, if you notice, there are a couple of other data stores here on the right-hand side. There is this data store, right, and this data store. So these 2 data stores are actually receiving transactional data every so often, every X minutes, using some kind of a replication service. So if it's file shares, you could use something like, if it's all stored in the SAN, you could use something like SnapMirror with NetApp. Or if it's a database, if it's Oracle, use DataGuard and dump transactions across on the other side. Or if it's SQL, we used InMarge, which is another product which works very well with transactional data. So this transactional information would get pumped across every X minutes to the other side. Now, what happens when you have a disaster? When you have a disaster, this whole environment is gone. The left-hand side environment is gone. So what we ended up doing was it was a multi-step process where we repurposed the web servers and the app servers to stop pointing to the validation data stores, and we would make them point to the replicated data stores. So it would no longer be serving the validation mode. It will now be serving as the DR production mode. And then we would use something called, we had Cisco's ACE, which is a load balancer device, and Global Site Services. We would use those packages to abstract the URL. So app.url say ecm.usdatamanagement.com would be repointed to the web servers on the secondary data center. So the users themselves, they would have a blip in performance where when the disaster did occur, but when we recovered the environments in the DR mode, they still had to log on to the same URL. Also, if this system was interfacing with another external system, if you use the same level of abstraction, you would still have no loss in functionality. Those applications would still be able to access this application that was failed over. So that was the way the secondary environment or the standby environment was designed. So hurdle 2, of course, is you want to make sure that the transactional data gets replicated on an ongoing basis to the secondary data center. So based on your recovery point objective, meaning how far back, how much of information can you lose? Your recovery point objective is, say, 2 hours or 15 minutes, etc. We would make sure that we replicate that data within those RPOs. The typical types of transactional information, perhaps it's a file share, perhaps it's some files, it's some flat files that are stored on a SAN. You can use SANs, replication technologies like SnapMirror, etc., to transfer that data across. Perhaps it's a virtual machine itself. The entire virtual machine needs to be replicated, and you can use Site Recovery Manager to have a ghost VM on the other side, which can be turned on in case of a disaster. And you can use Site Recovery Manager and VMware to achieve that. You could have Oracle databases, and you can use something like DataGuard to push transactional data across. A SQL database, we could use InMage or SQL replication itself to send some data across to the other side, etc. And of course, we are in a life science environment. So any of these services that we use and we can reproduce, we would qualify them and make sure that SOPs exist on how to deploy these replication services across different applications. The advantage of that is you qualify it once, and then it's more like an IQ and less of an OQ to verify the data is actually getting pumped across to the other side. So hurdle number 3, so we have a standby environment. Great. We have the transactional data that's getting replicated across onto the other side. Now we just need a standardized way or a standardized method to recover and change that state of the standby environment to the production environment. So SRM is a VMware plugin that was used, and we use this to store recovery plans for each and every system. So every application would have its own recovery plan. And how many of you are really familiar with SRM? Can I take a quick poll? You can just reply by private chat or public chat. Are you familiar with Site Recovery Manager for VMware? Okay. I just got one response. There was no. The other response was yes. But I'm going to kind of walk through this at a very high level. And if you have further questions about this, Josh or anybody else, we can discuss this offline as well. So essentially, SRM can contain recovery plans, which is it's like I wouldn't call it an orchestration tool, but it is like a sequential step-by-step run book. So you can which contains 3 types of things. One is you can put batch scripts, so you can put a batch file, for example, to start and stop services, or you can put a batch file to change some configuration files, etc. And you can also have message steps. You can put a sequence of messages for an operator to perform, say, hey, okay, make sure that the replication is cut off and actually activate the standby database. Say if we couldn't script that for some strange reason, you could actually put some message there and make sure that the application can be recovered. The third kind of step is since Site Recovery Manager is obviously it's a VMware plugin, so it works very well with virtual machines themselves. Say your disaster recovery solution requires a bunch of virtual machines that are associated with this application to be recovered on the other side. SRM can do that for you. So you'd have a bunch of shadow VMs on the other side, which can be activated by SRM in case of a disaster. So those are the 3 types of steps that you can have. And recovery plans can be manually executed by an operator to achieve system recovery. So this is a typical recovery plan. This is how a recovery plan looks. As you can see, the top 4 or 5 are message steps. Then there are a bunch of scripts, a batch script perhaps. You can start and stop services, say. and again, a couple of messages again, and then actual VMs can be failed over. So Site Recovery Manager is essentially a plugin. Just to talk a little bit more about how virtual machines themselves fail over. As you can see at the bottom here, and I'm going to turn on the annotation. Oops. Thank you. So we have two, the storage area networks here, and there is replication going on using SnapMirror, etc. The actual host machines that store the virtual machines are depicted here. And Site Recovery Manager can be used to fail over individual virtual machines onto the other side. I'm sorry, I really don't draw very well with a mouse. So this is how an SRM plan would look. And if you recall, earlier in my slide, I told you we needed to have we designed the standby environment to also support dual roles. So technically, we really didn't need to fail over the virtual machines. The standby environment had all the virtual machines that it needed to operate. So it had the web servers, the app servers, the database servers, etc. We just needed to swing the state. So we needed to change the state of the standby environment from val mode to production mode. So that typically contained steps, a bunch of sequential steps. So most of our recovery plans started out with a warning message saying, hey, are you sure you want to recover when you run this? You are failing over this application from the primary data center to the secondary data center. Then just in case there was the disaster wasn't a true disaster, it didn't take out everything, you might want to put a message saying, hey, if you have some servers running on the primary data center, you want to make sure you switch them off. Any of your app servers or your web servers, your database servers for the application is running, you want to switch them off. So that's a message. The next step can be some batch scripts that automatically shut down services on the application-specific servers on the secondary data center, because ultimately you're going to try and swing the state of the secondary environment from a val mode to a prod mode. So you don't want to do that when services are running. You want to shut down some services and perhaps change some configuration information or connection strings to those data stores and move them across. Once you do that, then you activate your standby database and your file share. So if you guys are familiar with Oracle Data Guard, the standby environment is not accessible when you've set up Data Guard. So you need to actually break that data replication and activate that standby environment, or activate the standby database. So you can use scripts. You can use some batch scripts to actually activate that environment. Then, logically, you need to make sure that activated data stores are accessible by the application servers and the web servers. So you really move some configuration files around or change some configuration parameters that will point the app servers and the web servers to the production data stores. So, for example, say it's a web app, you have some connection strings in your web.config file, right? Or there are some other connection strings on some XML file for the application. So you just make those modifications, swing the connection strings or the pointers from the val databases and the val data stores to the production databases and the production data stores. Then you can use some scripts to restart all of the services on the application side. And you can also instruct the operator to perform some basic system sanity checks, right? Log on, run a report, etc., make sure everything is working. And then contact your network administrators to make sure that the URL, the app.url, is now pointing to the DR environment. So I did talk a little bit about ACE and GSS. I've alluded to it already, but I just wanted to kind of talk about that at a very high level. So ACE and GSS are Cisco products. So in this particular company, we were using that from a load balancing perspective as well as server traffic control. And we also use it as an abstraction layer. So we abstracted the URLs like app or ecm.usdatamanagement.com is the URL that the end users were using, but that resolved to either a production data center IP or a secondary or data center IP, and we would manage that using these tools. So that's essentially how we used it, and that kind of really helps us from for a disaster recovery perspective, especially for the user. So the users don't have to remember, the primary data center is in Ventura, so it's VC app server 01 versus the secondary data center, say it's in Philadelphia, it's PHL app server 01. They didn't have to remember all of that. So it's just to use a URL, and that URL will always work. Oops, I skipped a slide. So, of course, we're in a life science environment, so we obviously need to qualify our underlying infrastructures, validate our applications. And since we are developing a disaster recovery capability for the system, obviously there are some requirements associated with that, and hence those requirements need to be tested and qualified. Plus, with Annex 11's latest guidance, where disaster recovery mechanisms need to be tested, et cetera, there's more emphasis on that as well. So from a validation and qualification perspective, any infrastructure tool that we used, especially any of those tools that we kept reusing, we qualified them, which is the virtual infrastructure, storage area network, replication technologies like Oracle Data Guard or InMarge or SnapMirror technology, et cetera, the ACE GSS, Cisco ACE GSS networking tool, as well as the Site Recovery Manager plugin are infrastructure services that we qualified, and we have standard operating procedures on how to deploy those technologies for different applications. So we don't have to keep reinventing the wheel and testing those aspects of it. We just had to test the recovery plan in our validation scope for the system. So individual recovery plans were actually tested, failed over, failed back, et cetera. So that was our qualification and validation consideration. So I think I stuck to time, and it's about 10:29, and I know we started a couple of minutes late, so I'm going to open the floor for questions. Again, like Becky mentioned a little earlier, we can take these questions even offline. You can email Becky, or you can pose your questions on the LinkedIn forum, and I'll make sure that I get back to each and every one of you. Any questions at this time?
So it looks like our first question is from Steve. Let's see. He says, how do we handle outages associated with specific set of systems, i.e., say only certain LUNs in the SAN are affected, which affect 20% of the systems? What if we need to fail over these systems, and how do we handle interfaces between the systems that have failed over and the ones that are still in the primary data center?
Let me see if I understand the question correctly. I think I think Steve's asking if we fail over, say there are 25 applications that are there in the data center. I'm just making up a number. If we fail over only 2 or 3 of them, how do we handle interfaces? Say it's a loss of just a few LUNs in the SAN, and only a few things are, few of the applications are affected, but not everything. So only a few things are failing over. How do we handle interfaces between each app? That's an excellent question, and it's not a very easy question to answer. So remember I was talking about abstracting the URLs. GSS and ACE should be used, those same kinds of URLs should be used when designing interfaces between applications. So a classic example, I'm actually, we're doing, this customer has Oracle eBusiness Suite, and it interfaces with Agile Ship, which is a label shipping or a FedEx shipping application. So we have abstracted EBS as ebs.usdatamanagement.com, for example. We've also abstracted this Agile Ship tool as agileship.usdatamanagement.com. So when EBS talks to or attempts to connect to Agile Ship, it's using the abstracted URL, and vice versa. So Agile Ship is sending feedback back to EBS. It's using ebs.usdatamanagement.com. What that helps us with is it doesn't matter where these applications are virtually or physically residing, meaning it could be in Ventura's data center, it could be in the Philadelphia data center, it doesn't matter. As long as the URL properly resolves, the connection strings between these applications only store the abstracted URL, if that makes sense. I hope that answers your question. Of course, there are some scenarios, and we encountered some scenarios where we could not abstract it because the tool resolved it to the fully qualified domain name and the actual IP, etc. And we had some scripts that would update those IPs automatically using SRM, but we did not. It's not a fail-safe solution. It's not a fail-proof solution all the time, but it can be done. I hope that answers your question.
Josh asks, sure. I think Josh asks, what type of infrastructure do you recommend for replication of transactional data?
Josh, that purely depends on what kind of replication data. So with Oracle databases, of course, Oracle Data Guard works, and that was something that worked very well for us, and we could push transactional data across that way. For SQL databases, we used a tool called InMarge, which has its pluses and minuses, and anything that can be files and such. We would also use InMarge, or we would use SnapMirror technology, etc.
I see a question from Kate. She'd like to know about IP address changes. If we use SRM to fail over entire virtual machines, how can we ensure the IP address is updated in the new data center?
Okay. So you're assuming if a VM completely fails over, you want to set a new IP address to that VM, and obviously when you fail over that VM, I think it retains the old IP address. If I'm not mistaken, there is a built-in tool within Virtual Center, especially if you're using VMware. There's a built-in tool called IP config or configuration something, and I can get back to you on the details about that, which essentially is like a lookup table, or it's essentially like a parameter table. So you can tell the shadow VMs that if you ever boot up, please boot up with this IP and not with the original VM's IP, and that works seamlessly. And I'll tell you the name of that tool. I'll respond to you via email.
Thank you, Subbu. Looks like one more question. What about failing back after disaster is averted? How can we handle this?
Oh, I think that's a good question. So I didn't talk about that at all. I just talked about failing over. So when you have a disaster, you can fail over. You can build the same. You can build a similar kind of a recovery plan to fail back. Of course, there are certain assumptions that need to be in play here. You need to have the same environment back up on the original primary data center. You also need to be able to reverse replicate the transactional data. Obviously, you've failed over, and you've probably been running in the secondary data center for a few weeks or a few months, depending on the type of disaster. And you've created new transactional information, so you want to make sure that you reverse replicate or you bring that back to the original data center. And then you can kind of set up an exactly similar type of a recovery plan where you fail back. In fact, for this customer, we have failover, failback plans set up and qualified because there was a scenario where the storage area network itself needed to be updated, and that was going to bring a bunch of the whole data center down. So they wanted to make sure that they could swing over and swing back fairly easily, basically a planned failover and a planned failback. So we set up recovery plans for both failing over as well as failing back. And if you go through that, and this presentation is going to be online. If you go through that flow chart, I'm going to show that right now. Just like how you could fail over, you could have the same set of steps in reverse to fail back. So all of these arrows, instead of pointing to the right, would be pointing to the left. And you could kind of set up this similar kind of an environment. Of course, with the prerequisites that the data is already replicated back and this environment of the original data center has already been set up.
Thank you, Subbu. We do have another question from Satendra. He'd like to know what deliverables are maintained as part of the documentation for audit purposes, FDA and SOX inclusive.
I can get back to you on the SOX side, but I think it should be fairly similar. But from a documentation perspective, like I was mentioning, the underlying infrastructures that we used were qualified. And there was a qualification methodology associated. There are policies for qualification methodologies for this particular customer. So the infrastructure services themselves were qualified, and by the services I mean the virtual infrastructure, the storage area network, the ACE load balancer, the SRM plugin, and all of the data replication tools. The data replication tools included InMarge, it included Oracle Data Guard, and it included the SnapMirror technologies. I think the SnapMirror was qualified as part of the SAN. So all of those underlying infrastructures were qualified, and there were documentation to prove that, and there were SOPs on the use or the deployment of those services for new applications. So, forms to be filled out when you request data replication services, et cetera, et cetera. So there was a clear trail of documentation for setting up those environments with replication, for example, or anything else. And lastly, the recovery plans themselves were tested, and the testing was part of the validation package for that system. So if my enterprise content management has a recovery plan, that ECM validation package included a test for recovery. So we would actually fail over, and for this customer, we actually failed over and failed back. Plus, of course, it's also part of the policy to kind of test the recovery plan annually. And we actually fail over production to DR for each system. We stagger it. We stagger these systems over the year, and we actually fail over individual applications to the secondary data center, run there for a week, and over another maintenance window fail back. So that way we truly prove the resiliency of the system design as well as the resiliency of the recovery plan.
Thank you, Subbu. We want to thank everybody for joining us today. We need to honor our time constraints and give you back your day. We do trust the information shared has been helpful, and we, of course, welcome comments or feedback that can assist us with continual improvement, and we're certainly open to suggestions for future presentation topics. This webinar has been recorded and will be available on our website, which is usdatamanagement.com, and we encourage you to join our discussion on LinkedIn and to visit the website to review topics for upcoming webinar events across the USDM practices. On behalf of the USDM team, we appreciate the opportunity to team with you toward excellence in compliance. Have a wonderful day.